Hey everyone, welcome back to another video from 𝗏𝗏𝗃𝗏𝗃. So today we are going to discuss the problems under Codechef Contest Starters 203 under Division 3. I'm Sanjay Kumar. Let's get started. If you look at the first problem, passing grade. Chef is in a class of his university with a total of n students. Chef's professor like Chef but hates the entire class. A big story of Chef as well as his professor along with his friends is given here. It was said that the Chef's professor will actually love Chef but hates other people. So, so hates in the sense he tries to fail other people as by giving a particular cutoff for this particular problem. Yes. So Chef's professor cannot change the marks the students received, but he can decide the cutoff marks. So he wants to ensure Chef passes, but at the same time fail as many other students as possible. Formally, that indicates that Chef should pass and others should fail, as maximum people should be fail in this particular problem. Yes. And it was given that the Chef is present. The chef is a student number one. In the given array of n students, the chef is present at the first position and other students are from number 2 to n. This basically says the array is not 0 based index, the array is 1 based index. Yes, and the chef is present at first index and I need to find how many maximum people will be able to pass in this particular test which was given by the chef's professor. So that was the same. Find the number of students that passes the chef passes the class when chef's professor chooses the cutoff in the optimal way such that minimizing the number of students that pass, ensuring chef passes. Yeah. So if we try to look at this particular example, 100, 59 and 98. So if 100 is a chef score, 59 and 98 are the other score. So if the chef's professor put 100 as a cutoff, so only chefs will be able to pass. So for this reason, output is going to be 1. So for the second example, chef got 0 marks. Even if chef's professor put 0 as a cutoff, so chef will be passed, other 3 friends also will be passed. So for this reason, 4 is going to be output. So how can we solve this? It's a very good, very basic, right? Very basic. So we're going with Java for this particular problem. So this is all about reading the input, taking n value, taking the array. Let us do one thing. Let us call this function count greater or equal, passing this lst n, and let us now implement this particular function. Yeah. What does this function says? What does this function should actually return? It should actually return the number of people who passes this particular test. So for this, can we just simply go with the count of number of people who passes, initial to be equal to 0, count to be equal to 0, and in other sense, can I say obviously Jeff professor will be putting it such that Jeff will definitely pass the exam? Yes. So can I say in other ways, Jeff will definitely pass. So count of number of people who passed without placing a cutoff is also going to be 1. Now, Jeff is at the first position. Can I just simply iterate on the leftover other page? Yes. So can I just simply go with her int I to be equal to 0, I is less than n, I plus plus. Inside this, are we really required to go with chef? Even if it is 1 based index, can't we just simply go with offset by 1, saying that 0 based index? So if it is 0 based index, I can say chef is present at 0th index. So I can just simply go with starting from 1 because I can just simply omit chef because chef already passed the exam. Yes. Now can I say if the list of basically the grade that each and every person got, the list of I, if it is greater or equals to the mark that chef has got, list of 0. Now can I just simply say, yes, the particular person passes, count plus equals to 1. Yes, and else he's not going to be passed. I'm not going to take it anything. Okay, and finally I'm going to return this count. I guess this logic is clear for everyone. Reaching end of while passing. So we got 144. Let us minimize and try to verify with this input and output. It is 144 and we got the same 144. Yep, all the test skills got passed. Okay, moving on to the next problem. Cab rides. Chef and his family is trying to reach the airport. Including Chef, there are a total of n members. A single cab ride costs max of 200 or else 100 times of x. Here x indicates the number of people who are traveling the particular cab. Yes. And it was also mentioned that a cab can fit at most of 4 people. Chef may have to book multiple cabs in order to make his entire family move to airport. What is the minimum cost for Chef's family to reach the airport if they take cabs optimally? Yes. So I guess everyone understood the problem statement. As it says, Chef wants to go to airport. The maximum cost for the cab is going to be max of 200 comma x times of 100. X basically indicates number of people in the cab. Yes, and this could be minimum of 1 and max of 4. This could be minimum of 1 and max of 4. And if there are n people present along with Chef, and he needs to find to book cabs optimally such that all the n people will reach the destination, which is the airport, with as minimum cost that is possible. Yes, I guess everyone understood this problem statement. How can we solve it? Let us take some example for this. So in the first test case, it says like there is only one person. If there is only one person, obviously one cab should be required. Yes. So one cab in a sense, max of 200 comma x into 100, which is equals to 100. So 200 as well as 100, which is going to be 200, the maximum. Later comes 4. If it is 4, I can just simply place all the 4 people in a single cab. It's going to be 400. So for this reason, it goes like 400. For the next one, if it is 5, if there are 5 people, can I just simply go with this? There are 5 people, and what always I can place? And basically I can say I can go with all 4 in one and one in one other. So if I go with these kind of thing, it's going to be like 400 over here. But this is going to be one person, as he is going to be only one person. It's going to be 200 over here. Yes, and in total it's going to be 600. 600. Is this the only way to place? Is this the only way to arrange? No. If you take 5, can't I just simply place all 3 people over here and 2 people over here? If it is 3, it's going to be like 3 times of 100. It's going to be 300, and it's going to be 2 times of 100. It's going to be 200. Even if it is 200, or even if there are 2 people, it's going to be 200. So over here it's going to be 500, which is the optimum. And even if I try to go with a different approach, it's going to be 2, 3 and the same. And if I go with one other approach, it's going to be 1, 4, and which is same as this. The only possible ways over here is going to be like 1, 4, 3, 2, 2, 3, 4 and 1. I'm not going with all like 1, 1, 1, 1 or else 2, 2, 2, 2, 1 in this particular mail. I mean to say like only once a particular cab is filled, I'm just simply going with the other, which is a very greedy kind of approach. But instead of going with this, if I can simply go with some optimal, and this finds us to be the optimal way of placing such that we'll be getting 500 as the minimum cost to reach the destination for the chef. Let us go with some other examples as well. Let us say if it is 6, if the value of n is equals to 6, if it is 6, I can just simply go with like 4 alongside 2. If it is 4 and 2, it's going to be like 400 over here and 200, which is going to be 600 in total. And if there is other way of arranging, can I just simply say 6 can be something like 3 alongside 3? Yes, in this particular case, what we basically get 300 over here, 300 over here, which in turn once again says 600. Any other best possibility other than this? If it is 6, can I go with 2, 4? This is same as this. So I'm going to eliminate this. Same as this. I guess you guys got some enough clarity on this. So let us give some key observations over here. from this key observations. Can I say like if it is 4 people, can I just simply go with one alone cap? Yes, one cap. If it is, let us say, like 8 people, can I just simply go with two caps? Yes, two caps. Yeah. So if it is a multiple of 4, I can just simply go with n by 4 caps with all 4 in. I basically mean with all caps with 4 in all. With 4 in all. Yes, n by 4 caps with 4 in all. Any other way? Just look at this. Yeah. So this is one way. This is one way. Let us say there is only one person. Even if there is only one person, even if there is only one person, can I say the cost that is required is going to be obviously 200? Yes. If let us say it is if there are two people, it's going to be like two in the sense. And once again, it's going to be the minimum cost, which is going to be 200. Let us say if there are three people, now it's going to be 300. Yes, now it's going to be 300. The only case that we are supposed to handle over here is this. Yes. So over here, it seems like 600. It seems like 600, which is 400 plus 200. In other way, we can just simply say total cost is going to be the cost for every person multiplied with 100, which is going to be just 500. The total cost is going to be the cost for every person multiplied with 500, which is going to be 500. In other terms, it means like placing 3 people over here, placing one person over here plus one other person, basically mean placing all 4 in two caps, placing all 4 in two caps, is it 3 in one and one other in one. The leftover one will be placed in the second one, which is going to be 3 plus 2, which is going to be 5 in this particular case. So approach is very simple. If it is this, we can just simply go with this kind of approach. If it is something like less than or equals to, we can just simply go with this. And if it is greater than this, we can just simply go with this. The number of caps that we require, number of caps. Obviously, how many caps are we required? If there are, let us say, 8 people, how many caps are we required? In optimal way, 2 caps. If there are 9 people, how many caps are we required? Once again, 2 caps for all 8 people and 1 cap for one person. In other terms, saying 1 cap for one person, I can say for nine, I can say it as 4 people over here. I'm left over with 5. We have also already seen, if it is 5, I can place 3 people over here and 2 people over here. Yes. So that means I mean to say the 9 can be divided as 4 as well as 5, and this 5 can be modified as like 5 can be divided as 3 as well as 2, and which is going to be 4 plus 3 plus 2, which in turn is going to be once again 9. So over here it is going to be one entire cap which costs us 400. Over here it costs us 300. Over here it costs us 200, which in total we basically say the total cost is going to be once again 900, which is equals to the total number of people multiplied by 100, which is equals to the total number of people multiplied by 100. Yes, I guess you got some enough clarity. Let us go back to the written and try solving it. Let us solve this problem with Python now. Yes, I'm going with input test cases, n as an input, and for every input, let us do one thing. Let us implement a function. Function name is going to be cap, right? Which takes the value n as input. As we have seen, if n is less than or equals to 2, I can just simply print what? Print 200 as an output. Else if n, I mean to say, if the value of n is multiple of 4, if n by 4 or else n modulus 4, if it is equal to 0, then can I just simply say print n by 4 times of 400? Yes. If n is less than or equals to, I'm going with printing 200. If n modulus would basically mean the number of people are going to be like multiples of 4. If it is 4, I'm going to print like n by 4 into 400. Any other case? Any other case? Okay. Else, I need to print n by 4 times of 400 plus n modulus 4 times of 100. As we have seen, if it is 9, it's going to be like 9 by 4, which is going to be 2. 2 times of 4, it's going to be 8 plus 800 plus 100, which is going to be 900. And this is for if it is 4 8, this is going to be this particular case. And if it is less than or equals to, this is going to be this particular case. Let us call this function average, passing this value n. Let us run this and see if you have handling all the cases or not. So we got like 2, 4, 5, 6 hundreds. So 2, 4, 5, 6 hundreds. Are we missing any of the cases? If it is less than or equals to 2, yes. If it is 4, or else, let us say if it is 5, this is being handled. Okay, let us submit this and see. Yeah, and all the risk is got passed. I guess this is clear for everyone. Moving on to the next problem, maximum MST. There was a weighted undirected complete graph of n vertices with m basically number of edges, one edge between every pair of vertices. Basically, it's a complete graph. As it is a complete graph, there exist n into n minus 1 by 2 edges, obviously. Unfortunately, the weights have been scrambled, and while we have recovered the multi set of weights, we don't have like which edge had which weight. We don't have the data like which edge had which weight. They were given the sequence like weight 1, weight 2, weight 3, and so on, m weights. Among all possible assignments of weights, what is the maximum possible value of minimum spanning tree? Yes, I guess people who are watching this video are already aware of something called as minimum spanning tree. If not, just try watching something like as minimum spanning tree and come back to this. So talking about this, it says like among all possible assignments of weights, what is the maximum possible value of minimum spanning tree? Okay, let us do one thing. Let us take a simple graph. Let us take a complete graph. Let us say there is a graph of 3 vertices. 3 vertices. If it is a graph of 3 vertices, how many edges exist? How many edges? If it is 3, the number of edges are also 3. This is vertices, this is edges. Yes. Or else, if I take 4, then this is 1, this is 2, this is 3, and this is 4. As this is a complete graph, can I say there exists an edge from every vertex to every other vertex in this particular graph? So there exists an edge over here, there exists an edge over here, there also exists an edge over here. Yes, these are all the edges from 1, and moving on, there also exists edge from 2 to 3, they also exist, and it's from 2 to 4. In the same manner, from 3 to 4 is going to be the last one. So how many we got in total? How many we got in total? This is the first, this is the second, this is the third one, this comes to the fourth, fifth as well as sixth. That means for n is equals to 4, we got like 6 edges. So for 4 we got 6 edges. This is vertices and this is edges. What is the relation between these? It is like 4 times of 3 by 2, so it's going to be 6. So it's going to be 3 times of 2 by 2, which is going to be 3. So if there are n vertices, the number of edges in this complete graph is going to be n times of n minus 1 by 2. Yes, basically if there is a, in this particular case, if I say this as a, b, c as well as d, from a there exists edge from a to b to c as well as to d. If it is b, there exists an edge from already b to a is done, is same as a to b. So I can just simply go with C and D. If it is C, there exists only from C to D, and D to C is also same as C to D. Yes, yeah. So that is the reason we got all 6 edges. 6 edges. So what the question actually says, you are given the complete graph. You're also having a weight for every particular undetected edge. The thing is, you are not having the proper data that which particular weight belongs to which edge. You lost this data, but somehow you need to construct a minimal spanning tree with maximum possible value of this minimum spanning tree. Yes. So let us take simple example. Let us take an example. Let us go with the second example, which is like 1, 2, 3, which is of 3 vertices. 3 vertices, and this number of edges are going to be 1, 3, and 3. Yes. 3 vertices and 3 edges. So as it is 3 vertices, 3 edges, this is going to be the graph now. 3 vertices and which contains 3 edges. If I say this as vertex A, vertex B as well as vertex C, and if I make the weights as 1, 2 as well as 3, 1, 2 as well as 3. So if you look at the output says 3 for this. The output says 3. Yeah. So talking about MST. Popular algorithms to find MST is going to be Kruskal's and Prim's algorithm. So we know the Kruskal's algorithm and the Prim's algorithm. I guess everyone is aware of this. Let us take the Prim's algorithm, which is the simplest of all, simplest of the both. So what do we basically do in Prim's algorithm? So we try to sort the edges, sort the edge weights along like according to the order, basically the one which is smallest comes first, as it is an MST, which basically take the first which is the smallest one will be considering first, and the larger one will be taken later. Yes. So if I try to construct an MST, people might think the question says, among all possible arrangement like assignments of weights, what is the maximum possible value of the minimal spanning tree? What is the maximum possible value? Maximum possible value is the question. The question says the maximum possible value. So what maximum possible value? Let us go with the statement over here. Maximum possible value with MST is what we require. The maximum possible value with MST is what we require. So it should follow the conditions. It should follow all the conditions of MST. Alongside, it should also take the maximum possible value for this. So people might think for this particular graph, so can't we just simply make an MST subset which contains all the 3 vertices, which is A, B and C, and saying the weight of this is going to be 2 and weight of this is going to be 3, and which in turn says 2 plus 3, which is equals to 5. but the output is still 3 but not 5. 5 is maximum compared to 3. But over here, this is completely wrong, because MST in the sense which should follow some particular conditions. Basically, it says take a minimum path, go with a minimum path. Firstly, go with a minimum path and try to maintain like such that everything like the graph will be connected and the graph will not contain any cycle. Yes, the graph will be connected and the graph will not contain any cycle. So in this particular case, the graph is connected as well as the graph is not having any cycle, but the first condition is misused such that we're supposed to go in a path which takes the first, which is a minimum weight. We are supposed to go with the minimum MST in the sense minimum spanning tree. So if I want the minimum spanning tree, can I go with this kind of assumption? Can I go with this kind of idea? Just look at this. If I'm having as the weights are not in a proper order, like as the weights are not having a proper data, which weight belongs to which particular edge, can we go with this idea saying that what I'm saying is let us do one thing. Let us let us maximize the value. If we want the maximum value, should we consider the minimum values or the maximum values? Yes, if I want maximum values, obviously I should consider maximum value. If I want maximum, then can I just do one thing? Can I make the minimum edge weight to be part of the cycle? If I can somehow make the minimum edge weight to be part of the cycle, then I can just simply eliminate this minimum edge weight and consider the maximum that is possible. Yes, and consider the maximum that is possible. Just look at this. As the edges are something like 1, 2, and 3, if you try to sort them, it's going to be like 1, 2, 3. Firstly, you're going to take 1. If I take 1, this is as A, B, C. So if I take one, it's going to be, let us say this is the path. Like if I take one, this is going to be one. As per MST, I'm going to take one. Done. Next comes two. Next comes two. Maybe two is present over here, or else two is present over here. Either possibilities is going to be either here or else here. So if I take two, is that forming a cycle? If I take two, like let us say this is two. If I take this two, is it forming a cycle? No. As it is not forming a cycle, I'm going to simply take two. And later, if I go with three, is this now forming a cycle? Yes, now it is forming a cycle. Now I do not consider this three. I guess this thing is clear for everyone. I guess this thing is. So output for this is going to be 1 plus 2, which is equals to 3 for this particular example. Yes. Let us do one thing. Let us take some bigger example for better clarity. Let us say we're having like 5 vertices. 5 vertices. Let us say the vertices are as A over here, B, C. Let us connect everything from A to B, A to C, A to E, and later comes B to C, B to E, B to D, and later C to D, C to E, and later D to E. Everything is connected. Now, if I try to add some weight, let us say the weights are in this particular sequence. Let us say the weights are like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because as n is equals to 5, basically the number of vertices equals to 5. We require like 5 times of 4 by 2, which is equals to 10. So I'm taking all 10 in this particular manner. Let us assume like the weights are something like this. Yeah. A to B is 1, A to C is 2, A to D is 3, A to E is 4, B to C is 5, B to D is 6, 7, 8, 9, I guess we're missing anything. B2C is done, B2D is done, B2E is also done, B is done, C2E is left over 8, C2E is left over, yeah. This is going to be 9 and this is going to be 10. So if I take something like this, now think of this particular case. Now I want to go with MST. If I want to go with MST, firstly, I am going to sort all the weights on the edges according to the weights. Sort all the edges according to the weights. So firstly comes first. Yes? Yeah. The first thing that comes is going to be first. Let me take this graph as well. A, B, C, D, E. Yeah. First comes the first one. So if I take this one, is this forming a cycle? Is this forming a cycle? So yes, it is not forming a cycle. I guess simply take this one. Next weight is going to be 2. One is done. Next weight is going to be 2. So if I take 2, is this forming a cycle? No, it is not forming a cycle. I can just simply take this. Next weight is going to be 3. Next weight is 3 is between A to B is done, A to C is done, A to D. A to D is equals to 3 now. A to D is 3. Yeah. So if I take this 3, is this forming a cycle? A to D, A to E, everything will not form a cycle. So you can just simply assume this way. But if I go with this kind of approach, what basically I say is we guys also may think like it's going to be sum of all n-1 numbers in this particular array from 1 to 10. You guys may also think like sum of n-1 numbers in this particular. Yes, but the thing is like this is not the right thing. This is not the right thing. This does not guarantee us giving us the maximum value of this MST. Does not actually guarantee us. Let us do one thing. Let us randomizedly take the edges, not just in the order as we took A, B, C. Let us just modify this. Let us take 1, 2, 3, 4, 5, 6, 7, 8, 9. One other is missing. This is 10. Okay. So start with the first one. One, I can just simply take it. Yes, I can take it. Next comes 2, is not forming a cycle. I can just once again take it. Next comes 3, is 3 forming a cycle? No, it is not forming a cycle. I can take 3. Next comes 4, A to E, is it forming a cycle? No, it is not forming a cycle. I can take 4 as well. Next comes 5. 5 is this. Yes, it is forming a cycle. I should not take this. Once again, this came out with the same. So it came out to be the same, such that like 1 plus 2 plus 3 plus, yeah, 1 plus 2 plus 3 plus 4. But is this the maximum value that is possible? Is this the maximum value? Just try considering this way. So we got like 1, 2, 3. Like it is not guaranteed that 3 will be present between D to E. 3 will be present between D to E. Can we do something like this? Can we place this 3? Can we place this 3 such that it forms a cycle in between, such that we omit this 3? I mean to say, instead of placing 3 over here, can we somehow place 3 in between this? I took 1, I took 2, and now I'm trying to place a 3 in between of B and C, such that it now forms a cycle. As it forms a cycle, I'm now going to ignore taking this value 3. I'm now going to ignore taking this value 3. And later I'll be taking 4, later I'll be taking 5, and so on in this particular map. I can just simply go on taking all these values. I guess you got some clarity on this. So if I try to take all these weights in this particular way, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I try to take all these weights in this way, so obviously MS in this, I should be starting with this value. I'm going to take this. If I take this, So it's going to be this. No cycle is formed. No cycle is formed. I'm going to take this. So if I'm taking this, there doesn't exist a cycle between three nodes with two values. What I mean to say is there doesn't exist a cycle with three nodes but two vertices. Sorry, three vertices with two edges. There doesn't exist a cycle. Now when I go with this, I'm saying like try to take a cycle such that this will not be taken. Like, try to consider a cycle exists such that this will not. Basically, if you can somehow consider this, there exists a cycle over here. So this is 3, so that I'm not going to consider this. I'm not going to consider this. So it's going to be, so far this is 1, so far this is 2. I'm not considering this. Done. Next comes 4, let us say. If I try to consider 4, the 4 could be anywhere, like 4. Let us say 4 is present over here. 4 is present over here. Yes. If 4 is present over here, next let us draw a node over here. Yeah, 4 is present over here. Next comes 5. Can I take this 5? Can I take this 5? So think of this like I want to maximize. I want to maximize in the sense, out of 5 vertices, I should be having like only 4 edge weights. Yes, only 4 edge weights. So far I'm done with 3 edge weights. 1, 2 and 1, 2 and 4. 1, 2 and 4. I should be getting the maximum. If I want to get the maximum, I should be somewhere else in this part. I should be present in this part. But if I try to consider 5 itself, I am not guarantee that I'll be getting maximum. So I do one thing, like I consider this as somewhere else over here. Let us go with yellow here. I consider this 5 as somewhere else over here, and I'm not going to take it. This is, let us say, 3, and this is, let us say, 5. Next comes 6. Next comes 6. Can we form a cycle with 6? Can we somehow form a cycle with 6? Yes, obviously I can form a cycle with 6. Over here I can form a cycle. If I form a cycle, I'm not going to consider even this as well. Yes. Done with this. Done with this. 6 is also done. Next comes 7. Next comes 7. What about this 7? What about this 7? So let us say this is A, this is B, this is C, this is D. One other node is left over. Let us take this as E, node E. Can we now place this node E? Maybe from D, maybe from E, maybe from B, or maybe from C. Anything is fine. Anything is fine. I can just simply take it from B, C, E, or A in this particular. So if I want to go with this, I need to go with the minimum, and I should be also eliminating the maximum, which is forming a cycle. So is there any possibility that something forms a cycle with 7, with the edge 7? Any possibility of cycle? So this already formed a cycle, this already formed a cycle, this already formed a cycle. There is no possibility of forming a cycle. Now I'm going to consider this as another edge of weight 7, as I'm going with the order of MST, of taking the minimum first and placing the maximums in the cycle such that this will not form a cycle. If I go with 8, obviously I can make something like this forms a cycle. I'm not going to take this. I can make something with this on from E to B, that does not form a cycle. Or else I can form from like A to E is one cycle, B to E is one other cycle, and C to E is one other cycle, which is going to be 8, 9 and 10. So I'm going to place all these 3. I'm going to eliminate such that these forms a cycle. So with this I can say like 1 plus 2 plus 4 plus 7 is going to the maximum value of minimal span tree in this particular case. So this is going to be output for this particular case. In this case, it's going to be 14. 14 in this particular example. I guess this particular thing is clear. The thing is, somehow we need to take these values. Somehow we need to take these values. I need to take firstly this. Later I need to take this. Later I need to take this. Later I need to take this. I guess you guys are getting some enough clarity on this. Let us take also a different example. We went on with n is equals to 5. We went on with n is equals to 3. Let us go with like n is equals to 4 now. If n is equals to 4, let me take like n is equals to 4 in the sense 4 times of 3 by 2, which is going to be 6 in this case. Let us randomly to take 1, 2, 3, 4, 5 as well as 6. I'm equal of 4 vertices and 6 edges. Let us take the first vertex, and obviously I need edge in the sense I'm required of a second vertex as well. I'm going to take this initially MST value is 0. Now it is 1. Now it is 1 with an edge between 1 and 2, which is going to be 1. Done taking this. Now let us go with this. Can I take this? If I take this, is this forming a cycle? No, it cannot form a cycle. Basically, let me first draw all the 4 vertices. Yeah. If I take 2, is this forming a cycle? If I take 2, basically this could be something like that. Either this could be this, or else this, or else this, or else this. Anything is fine. Anything is fine. Is this forming a cycle? No, it is not forming a cycle. I can take 2 over here. Now this value is going to be 2 plus 1, which is equals to 3. Now, if I take 3, is there a possibility that it forms a cycle? Yes, I can take 3 here, and which forms a cycle? Getting the point? I'm trying to eliminate this value. I'm trying to eliminate this value as this is the maximum. I'm trying to eliminate this. So as I eliminate, this forms a cycle as I eliminate. So I'm going to eliminate this. Later moving on to 4. If I go with 4, like let me draw this. Yeah, done with this. If I go with 4, any possibility of forming a cycle in these 3 vertices. If I go with 4, any possibility of forming a cycle. So obviously 3 vertices already, 3 edges are done. I cannot go with one other extra edge, so I should be joining the 4th vertex. If I want to join the 4th vertex, either this is the possible path, or else this is the possible path, or else this is the possible path. Is any of these paths, either this or else this or else this, is any of this path forming a cycle? Yes. So if I try to look at this is not forming a cycle. This is also not forming a cycle. Even this is not forming a cycle, which becomes this. If I take this, it becomes this, and if I take this, it's going to be this. So which is not going to form a cycle. So now I'm going to consider maybe over here, which is going to be 4. I'm going to consider this. Done. And later forming cycle is going to be either these two will be forming a cycle. So in this particular case, 4 plus 2 plus 1, which is going to be 7, is going to be output for this particular example. I guess you got some enough clarity. So the thing is, we need to understand some pattern in this particular case, some pattern. So if I try to look at this value is being taken, which is the minimum value, which is obviously being taken. This value is also taken, which because if there is only two vertices, like if there are only 3 vertices, there is no chance of forming a cycle with the help of 3 vertices and 2 edges. There is not only a chance of forming a cycle. So I'm going to take these two. I'm going to take this thing, and I'm going to eliminate this. I'm going to eliminate this. Later, I'm going to take this, and it forms under a particular pattern. And let us deal about this pattern now. Just look at this. Initially, just look at this. This is at 0th index. From 0, we went on to 1, and from 1, we went on to. Let me go with the indices. 0, 1, 2, 3, 4, 5. From 0 we went to 1, and from 1 we went to 2, 3 in this way. So what is the relation over here? Can I say plus 1? Can I say plus 2? Yes, then this is a relation. Just look at this. Look at this as well. From 0, let us go with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. From 0 we are going to 1. From 0 we are going to 1, and from 1 we are going to 3, and from 3 we are going to 6. What is the relation that you can see here? Plus 1, plus 2, 3 plus, in the sense, plus 3. Even if it extends like plus 4, do we have 4? 1, 2, 3, 4. 4 doesn't exist. So I can just simply stop in this particular case. So because of that reason, we got the output over here as 14, and because of this reason, we are getting this output as this. And let us also go with the given input cases. If it is 1, 2, 3, if it is all 6 files, yes. As it is 1, 2, 3, as it is 1, 2 and 3. I can just simply take this with this, and later I should be taking 2 plus 1, which sorry, plus 1 is this, plus 2, which is not possible, so I can just simply take 1 plus 2. If I take 5, 5, 5, 5, 5 and 5, I can say like plus 1 is going to be this, plus 2 is going to be this, yeah, plus 3 in the sense over here, which is not practically possible. So plus 1 plus 2 is going to be 5 plus 5 plus 5, which is equal to 15. So that is the reason we got 3 as output for this, as well as 15 as output for this particular example. Okay. So even with not enough, like even if theory knowledge of MST can also complete this particular problem. Let us go with this and let us complete this particular problem. Let us code this up. Yeah. So let us code this in Java. So the key things that we are supposed to notice in the input format, the first line is number of test cases, and after every test case, you are given the number of vertices in the graph, and later m values, which are the number of total number of total edges, total weights of the edges. So we are not dealing with edges as an input. So only n is given as an input, and I'm taking the value of m as going to be n into n minus 1 by 2 number of edges, and I'm taking an array in this particular way, like I'm declaring an array of size m, which is n into n minus 1 by 2. Let us take the input for this like in this way, and let me call this function maximum MST, which I'm passing this y weights array, number of vertices n and number of edges m. Let us quickly implement this. So as I said, we need to find maximum possible value. As if we want like maximum possible value. So maximum value should be like, if it is possible, take the value as a cycle, make the value as an edge which forms a cycle. So eliminate it. So if I want to go with this, obviously I should be getting a sorted form, because I should be firstly sorting according to Prim's algorithm. What should I basically do? I should be sorting the edges according to the weights. So we are already given the weights of the particular edges. Let us do one thing. Let us sort the edges. Arrays dot sort of the weights w. After sorting this, what is the next step? I'm required something like answer to be to the output, int answer to be equals to 0 in the very start. Alongside, yeah, let us do one thing. Let us iterate on this as how we discussed. Let us iterate and let us move on to the logic. Yeah. Can I do one thing? Can I keep track of this particular indices? Keep track of this particular index and adding this particular value at every point of time. Yeah. Let us say int idx equals to 0, and let us go with the for loop. So let us say int I equals to 0, I less than n minus 1, because n vertices, n minus 1 edges are going to be present in MST. N minus 1 I plus plus. What should I basically do? I need to firstly add the first one, which is present at 0th index. So can I just simply say answer plus equals to array of 0, In other terms, can I say array of idx? Yes, array of idx. Answer plus equals to array of idx. And what about this idx for the next time? This idx should be pointing to look at this. Initially, it is pointing at 0. Later, it should be pointing to 1. Later, it should be pointing to 0, 1, 3. From 0, it should go to 1. And from it should go to 3. What can I do for this? Initially, this is IDX. Can I add I to this, saying that 0 plus 1 is going to be 1. And later, 0 plus 1 is going to be 1. And later, like if I go with this, I need to add plus 2 to this. Can I do something like this? Instead, idx plus I, and say idx equals to idx plus I. So idx is going to be idx plus I for every time, and I'm going to add the initial index plus the value which I need to add at every point of time. Initial index plus the index, and this is the value that I'm going to get. And let me return this answer, that whatever we got. So this is the whole logic. I'm sorting the array of weights, I'm done taking this answer to be 0, idx to be equals to 0. I'm iterating in this particular manner, I starting from 0 to n minus 1, answer plus equals to array of idx plus I, and idx equals to idx plus I. I'm going to return this answer finally. Let us go with the semicolons. Let us run this and see what we're getting to the output. So the variable array is not present. It is not array, it is w. So we got 42, 3 and 15. Let us verify with this input and output. Yeah, it is 42, 3 and 15. Let us submit the same. Yep, all the test cases got passed. The logic is very simple. The logic is very simple. Go with the MST logic. Go with the first minimum weight. As we go on, if we get some weight, try checking if a particular edge forms a cycle with the already formed graph or not. If it forms a cycle, try to consider it as an edge which forms a cycle and ignore it and consider moving further. That's it. Okay, moving on to the next one. Max on ranges. You're given a zero indexed binary string s of length n plus 1, and your task is to construct an array A of length n such that if Sx is equals to 1, basically if S of I, if I is equals like Si, if it is equals to 1, if and only if there exists LR such that in the range of 1 to n, this A is of 1 based index in the range of 1 to n, the max of A to L. Basically, max here says that minimum non-negative integer not present in the array. Max is minimum non-negative integer not present in the array. Max is minimum non-negative integer part of the array in the range of L to R. And you're supposed to construct an array in that particular array in the range of L to R. You are supposed to go with the kind of mix condition which is minimum non-negative integer part of this particular array. Yes. Uh, yeah. It will be better if you can somehow go with some kind of input and output. If you look at this 1100 and the output is going to be 020, 1100, the output is 020. Let us concentrate on this. As it is 1100 and this is of 0 based index, this is going to be 0, 1, 2, 3, 0 based index. As S of 0 is equals to 1, S of 0 as it is equals to 1, I'm expecting that they should exist a subarray, they should exist a subarray part of the array which contains the max equals to 1. So the max is equals to 0. When can there be a max which is equals to 0? Max which is equals to 0. As max says minimum non-negative integer. Minimum non-negative in the sense either this could be 0 or greater than 0. Yes? Can I say like greater than or equals to 0? Greater than or equals to 0 is going to be the max? Yes. So I want to get the max as 0. In this particular case, I want to get max as 0. Basically it says non-negative integer part of the array. So it is not part of the array. Yes. Non-negative, minimum non-negative integer not present in the array. A major correction for this. Non-negative integer not part of the array. Not part of the array. So 0 should not be present in this particular array. 0 should not be present in this particular array, and that to be 0 should be the minimum non-negative integer. So what could be the other value? Can I take 1? That means can I first choose say the array that you're trying to consider should contain 1? Should contain 1, or else like basically if it is of length greater than 1, or else let us look at this. If it is of length 1, can I just simply take an array of single value 1? Or else if it is of length 2, can I just simply take, or else, yes, I mean like, can I just simply take an array of single value 2? Even here, the max is going to be 0 because minimum non-negative integer which is not part of the array is going to be 0 itself, right? Because this itself is an array which does not contain 0 in it. This does not contain 0 in it. If I take a length 2, can I just simply have 2 in this case? Or else 2, 3, is this valid one? Is this a valid one? Yes, even this is also valid, which basically says the minimum non-negative integer which is not part of the array is going to be still 0. Yes, the minimum non-negative integer which is not part of the array is going to be still 0. If I take like 1, 2, this is also once again going to the same. 0 is not part of it. Basically says for zero, anything that you put in the array is going to be valid. Anything that you put, that means if the output is of length at least greater than 1, or if it is equals to 1 or as well, what I'm basically saying is if it is equals to 1, the length, if it is equals to 1, and if the array is not an empty array which contains, like if the array is not an array which contains only 0, then I can blindly say max for this obviously exists. In this particular case doesn't exist, because what is a minimum non-negative integer which is not present in this array? The minimum non-negative integer which is not present in this array is going to be 1, but I need for 0, so this is not possible. Only this case is not possible. For any other case, obviously there exists a max for this particular zeroth index. If it is of length 2, if it starts with 0, if it is going to be like 0 as well as 1, obviously I can just simply consider this particular subarray which is just 1 and say the max for this particular subarray is going to be 0, which is 0 doesn't exist in this particular array. So I can say in this particular case, for every other case which is length greater than 1, or else if it is equals to 0, length if it is equals to 0, if it is not equals to a subarray of 0 itself, it obviously contains a max for 0. And moving on for the next, if it is a first index, I should be having the max for a particular subarray to be equals to 1. What is it basically saying? Max should be equals to 1. If max should be equals to 1, that means 0 should definitely be present in the array. Yes, 0 should definitely be present in the array. Can I say this is an array which contains max equals to 1? This is the array which contains max equals to 1. Let us say if I want max equals to 2, when can it be possible that I can get max to be equals to 0? Obviously, only the chances that 2 should not be present in the array, but along with 2 is not being present, 0 as well as 1 should be present. Yes, if 0 exists, 0 is not going to be max. 1 exists, 1 is not going to be max. And if 2 exists, basically if 0 and 1 definitely exist, only then I can say the max of this particular array is going to be 2. In other terms, like if I say just simplify, let us say if it is just simplify, then max is going to be 0, not 5. Max is not going to be 0, like max is not going to be 2. Max is going to be 0 in this particular case. So you're not going to consider something like this. You're not going to. So this is going to be the major idea to solve this particular problem. This is going to be the major idea to solve this particular problem. So what can we basically do? It was also said that you are allowed to print any valid solution. Valid solution is going to be anything, and also given that you are guaranteed that for the given string is there exists a valid array. Obviously there exists a valid array. Alongside it was also said that guaranteed that s of 0 as well as s of 1 is going to be 1. S of 0 alongside s of 1 is going to be 1, and there doesn't exist anything that starts with 0 blindly. Anything will start with 2 zeros in this particular. So if I try to take this particular example, 1100 1100 1100. So now the case is this is 0th index, first index, second index, third index. I'm not at all going to bother about this. It was because it was said that s of 0 will be equals to s of 1 will be equals to obviously a single character which is 1. So I'm not going to bother about this, as I'm not going to bother. The length is obviously going to be equals to like greater or equals to 2, so obviously more than or equals to 2 elements exist. As 2 elements exist, obviously the element which is internal is not going to be 0. As it is not going to be 0, I can for sure say max for 0 exists. I'm not going to consider for 0. That is the reason, like, array size, if it is of n plus 1, the array size is going to be of only size n. Yes. So start from here, start from this particular index. Now I want the max of the array to be equals to 1. If it is 1, basically this is the 0th index, this is the first index, second index, third index, and fourth. Second and third index. I'm just ignoring this index. Talking about this index, the possibilities are going to be either 0 or else 1. Either 0 or else 1. It was said that this could not be 0. The only possibility is 1. If it is 1, I should be getting the max of the subarray should be equals to 1. Max of the subarray should be equals to 1. When can that exist a max to be equals to 1? Only when I say there exists a 0, only then I can just simply say, if it is something like an increasing order which contains 0, let us say it contains 2 now, 0 and 2. Now can I say this particular subarray contains a max which is equals to 1 itself? Or else taking 0 itself blindly says 0 is a subarray which contains a max to be equals to 1. Yes, the minimum non-negative integer not part of the minimum non-negative integer which is not part of the array is going to be 1 in this particular case. So I'm going to take if it is 1, I'm going to take 0 into this. Basically I'm going to say, let us say I store something like max to be equals to 0 in the very start. If it is 1, yes, as it is 1, I'm going to take the 0 into my array and update this to be equals to, like, this is the 0th index, this is the first index, second index, and third index. I'm going to update this to 1. Why I'm updating this to 1? Because this one I need to place into this array such that for the next time, if there exists a 1 over here, obviously 2 should be the max of the particular array. When can 2 be the max? If it contains 0 and if it contains 1, only then I can say 2 is a max for this particular array. I guess this thing is clear for everybody. Yeah. So now I'm going to say this is going to be the max. Yes. Now 1 is going to be the max. Next comes the next possibility. In this particular case, I can just simply say two possibilities exist, either 0 or else 1. If it is 0, I can blindly take 2 to this. And if it is 1, now I should be thinking like 0 is done. 1 should be the max. If 1 should be the max, what should it like? 2 should be the max. If 2 should be the max, I should be having 1 in my particular array. 1 in this particular array. Yes. So this is the concept. Moving ahead, if this is 0 or if this is 1, if it is 0, I can just simply take 3. Basically I'll be having 2 and 3, and for the next time I'll be taking like this particular sublet. Let us say if next thing is a 1 over here, fourth index, next thing if it is a 1, I can just simply say max should be 4. I can just simply take 3 and say 4 is a max for this. And in this particular case, if it is 1, 3 should be the max. When can 3 be a max? Only if it contains 0, 1 as well as 2. Take 2 in this particular case. And where come this 2 comes? When we updated this 1 into this and modified this 1 as a max. When we updated this 2 into this and modified this, and 2 is going to be max. Now when we go with 3, and I'm going to update this 3 in this particular case. So this is the way we can just simply complete this. The logic is very simple. I'm going to take max to be equals to 0 in the very start. I'm also going to take an empty array list. Max to be equals to 0. I'm going to simply traverse from I starting from 1 to n plus 1, because the string length is of size n plus 1. And I'm going to say if it is a character 1, I'm going to say update this. Let us say this is l dot add of the max whatever I am having, and modify this max to be equals to the value I which whatever we got. Else I can just simply say l dot add of this particular value I itself. So this is going to be the whole logic in which I am going to simply implement this. Let us code the same over here. Let us go with Python for this. As it states, n is the input, but the string length is of not n, it is of length n. Let me mention is n plus 1. Yeah, let us go with the full screen now. Now I can say s equals to input. Take this particular string as an input. Let me go with a function over here which basically returns me the max. Max range is a function which takes the value, which takes the string alongside the size of the string as the parameters. Basically, n alongside, yeah, n is fine, like s is fine. So let me take n equal to length of s. Now I'm going to say max to be equals to 0 as I mentioned. So I in the range of 1 to n plus 1, or else it is not really required to go with n plus 1. Basically, it is of length n. Yeah, 1 to n. I can say if s of I, if it is 1, now I'm going to say I need an array list. Let us say an array of size n is also fine and an array list is also fine. Yes. So l dot append of the value max and update the value of max to be equal to I. Later, if this is not the case, l dot append of the value I itself. Return this array list, whatever we got, and let me take answer equals to max range of s print answer. Let us run this, minimize the screen. So return L invalid syntax, forgot a comma. It is return. So we got 0, 2, 3, 0, 1. This should be like not form of an array. If I want, I can just simply print it in single separate characters, or else star on is also fine. So let us do one thing. Let us verify for the first one. If it is 1100, the output is going to be 023. 1100, the output is going to be 023. So this is 0th index, first index, second index, and third index. I want the max to be equals to 0. If I want max to be equals to 0, I can just simply take this particular subarray and I can just simply say in this particular subarray max is going to be 0. Yes, blindly I can say max is going to be 0. I want max to be equals to 1. When can I say max to be equals to 1? If I take this particular subarray, I can get the max to be equals to 1. If I take this particular subarray, I can once again get the max to be equals to 1. If I take this particular subarray, once again I can get the max to be equals to 1. For any of the three probabilities, max will be equals to 1. And over here, this is not equals to 1. I'm going to simply ignore this. Yes, whatever we got, let us submit and see what if it is the expected output. Yes, all the test cases were passed. That's it for this video. I hope you learned enough from this. And for more content like this, please like and share for this particular YouTube channel. Thank you.